Wonderful. Welcome to today's second distinguished lecture in social sciences. It's a great pleasure for me to welcome Charles Manski. He will talk about communicating uncertainty in policy analysis. Before handing over to Charles, let me briefly point out the major steps in his academic career and give you some insights into his really important and fascinating work. Charles grew up in Boston and studied at MIT, where he obtained his PhD in economics. As a PhD student, Charles felt that the core courses in microeconomics and macroeconomics were, as he puts it, decades out of date. He writes, "The material was taught as received wisdom set in stone rather than as the state of the art in a living science." I'm quoting this since this is exactly the criticism of the current generation of students that we get when we teach economics. But let's not discuss this today. Charles was a professor at Carnegie Mellon University, the Hebrew University in Jerusalem, and the University of Wisconsin-Madison before moving to Northwestern, where he's a professor since 1997. He holds honorary doctorates and is an elected member of the National Academy of Sciences, an elected fellow of the American Academy of Arts and Sciences, the Econometric Society, and many more. This year, for example, he has published numerous articles in the finest journals, no details here, and has written many books. This year, he has a new book on patient care under uncertainty, where he looks at decision-making in the domain of medicine. Now, let me talk about his work in a bit more depth, very briefly. In a very interesting autobiographical piece, Charles explains that he perceives his major breakthroughs as processes of unlearning and discovery. By unlearning, he means that he had to unlearn orthodox views and go back to the basic question. And so I will give you two examples of this. As a first example, Charles notes that he's always been troubled by the assumptions of convenience, routinely maintained in empirical research. The main goal of his work in econometrics has been to investigate what can be inferred under weaker and more credible assumptions than those commonly made. The problem with many assumptions of convenience is that they cannot be refuted. For example, consider the problem of how to deal with missing data and the assumption that this is random, which data are missing. Charles asks what inference one can make without any assumption about the process that generates missing data. This work is directly related to the problem of unobservability of outcomes under treatments that a person did not receive, namely the problem of counterfactuals. His approach is one of partial identification. This means characterizing the power of weak and credible hypotheses for identification and see how far one can get with them. His book entitled Identification Problems in the Social Sciences on this topic appeared in 1995. It has had an enormous impact on empirical work in the social sciences that cannot be overestimated. A second important theme of his work is measuring expectations, a topic that is of great importance also for behavioral economists. There are many behavioral economists in the room and at the WZB, among them Andy Schotter, actually, who was the first to elicit beliefs in the laboratory. But Charles's motivation to study expectations did not derive from behavioral questions, where incorrect expectations and biased beliefs have become central. Rather, he dealt with the so-called revealed preference approach of modern economics, so a very fundamental issue. And the idea is the following. Decision rules and preferences can be inferred from observing choices. And if a person chooses one option over others in her choice set, she must prefer this option to others, right? Now, the problem is that often the choice set and also the attributes of all the available options are not known to the researchers, okay? So what can you infer if you just see a choice, but you don't know what the available alternatives are? In theory, it's nice, but in applied work, it's difficult. So Charles concluded, as he puts it, I quote him again, that making progress requires new data rather than new methodology. Instead of making assumptions about how decision makers perceive their choice sets, we should ask them. Now, this is not an obvious approach. As Charles put it himself, I had been taught that a good economist believes only what people do, not what they say. But he goes on, I came to rethink my preconceptions about measurement of expectations for two reasons. First, I became aware that there existed no persuasive body of empirical evidence showing that expectations data are uninformative. Second, I became increasingly concerned that in the absence of data, economists were making unsubstantiated and often fanciful assumptions about expectations. This is the basis of his groundbreaking work on the elicitation of beliefs. I don't want to use up any more time and instead hand over to Charles. Without further ado, please let me join in welcoming him.
Thank you, Dorothea. That helps a little bit. I know this is a very broad audience, so maybe it helps a little bit. I was thinking, as Jennifer was talking, that was a very depressing talk about the external world, and I am to caution you, I am going to have to follow it with a depressing talk about our internal world of researchers, because as Dorothea was alluding to, I'm an econometrician. Econometricians within economics are not very well liked because I do empirical research myself, of course, but our colleagues who spend most of their time doing empirical research and they want to get results and say, well, I've shown this and this should be the good policy, and so on. Econometricians like myself are always saying, wait a minute, do you really do that? Can you really say that with any certainty? And so we're always, we're sometimes not welcome. And this whole talk will be along those lines. I'm going to say lots of things that are unwelcome to many well-meaning colleagues and friends. It's about, I think the relationship that really makes this really fit with the other talks today is that and in the WZB, people particularly wanted me to talk on this topic, is to talk about my work on communicating uncertainty and policy analysis, so particularly to how it ties in with public policy, which we've been discussing all day. So let me give some broad themes, and then we'll get into it. So the term policy analysis describes scientific evaluations of past public policies and predictions of the outcomes of future policies. And to me, it's hard to, this is really what drives me. It's not what drives most people, but what drives me is that I want credible policy analysis that explicitly expresses the limits to what we know. I think that's probably why I went into econometrics rather than a result of going into econometrics. I think that's always been important to me. And it has troubled me for a long time that the policy analysis that's done has this, what I've called incredible certitude. I first used that term in a journal article in 2011, and I continue to use it since then. What is incredible certitude? So we're going to be talking a lot about that the next hour. People, and I'm talking about my fellow economists, but the things that I say are really endemic across the social sciences. It's not just economics by any means. People they like to make exact predictions of what's going to happen, and to be very confident about, I think this is what's going to happen. Expressions of uncertainty are rare. If you push someone at a seminar, as an economists are tough on each other at seminars, you can get someone to back off or maybe give a caveat. But particularly when talking outside of academic audiences, people want to show a lot of confidence that they really know what they're talking about. My own view is that the predictions that we make as social scientists are often quite fragile, and as Dorothea was saying, that they often rest on unsupported assumptions and also on limited data. In those cases, people may express certitude that I have shown this, but that may be fragile, so the expressed certitude may not be credible. Now, let me give two leading examples. I don't want to be parochial American, but these are the examples I know best. There may be similar examples in many other places. The Congressional Budget Office is required by law to put out 10-year forecasts of the impact of pending legislation on the federal debt. And these things are called scores. Since 1974, when the Budget Act was passed, they're required to score the legislation. Now, the impacts of the new legislation are quite difficult to foresee often, but the scores that the CBO puts out are point predictions. That 10 years from, in the next 10 years, if this legislation is enacted, the federal debt will decrease by $138 billion, okay? That number doesn't come from out of my head. That was the actual number used for the Obamacare scoring back in 2009, 2010. They don't express uncertainty. If you go to the CBO, I've been to the CBO, I talk with people there. They're good economists. They all know there's uncertainty, but they say they're not allowed to express uncertainty. Okay. Second major class of cases in economics are official statistics published by government statistical agencies. Again, you can use the American context, but it would be the same in Germany or anywhere in the EU, is you put out GDP numbers, inflation numbers, poverty numbers, anything. They're put out as just numbers. Anyone who knows how these numbers are constructed knows that there's all kinds of uncertainty in all those numbers. There's basic sampling uncertainty for a lot of them, just ordinary statistical imprecision. But then there's also the kind of deeper kinds of uncertainty, the ones that we refer to as identification problems, where the manner in which the data are collected is imperfect and so on, measurement error, missing data, and so on. And so there's all kinds of reasons why these numbers are uncertain, but the numbers get put out, and they say the unemployment rate in the United States in let's say in October 2019, I think, well, it will come out this Friday, I guess. It might be 3.7%. That's the number that will come out, something like that. No confidence interval, no range, nothing like that. So that's typically the way things happen. Now, I want to give one counterexample of discipline outside of economics that does it right, and at least much, much more right. And that, again, in the American context, is the National Weather Service. And I think we are all used to seeing probabilistic forecasts of rain or snow and so on. And by far, the best statement from any government agency I have ever seen was this one that I quote here. This is Hurricane Harvey was bearing down on Texas. And the National Weather Service put out a tweet on this date. This event is unprecedented and all impacts are unknown and beyond anything experienced. And this was a government agency. This was not Trump's hurricane with the crayon. This was the real forecast from the National Weather Service. And we don't do that in economics. The National Weather Service does, but we don't. Let me give you a few sources, because I obviously can't go into this in all the detail that I would love to. The first book here on, it's not actually my first writing on this topic, on communicating uncertainty and policy analysis, but it's the place to start. Public Policy in an Uncertain World, 2013 book. This article is particularly on the statistics, on the GDP, poverty statistics, and so on, in the Journal of Economic Literature. This is an article that came out just this year with the title that I'm using for this talk, and it has all the references to anything I talk about today in the Proceedings of the National Academy of Sciences. Maybe the most fun is this one. It's available online now. It's not out in their published version. The Lure of Uncredible Certitude. The lure means the temptation to say things that you really can't back up because there's so many incentives to do so. So I had an opportunity to really let myself go on that, and actually to have a journal accept the paper. That was interesting. So you can see that. And then, as Dorothea said, what I really have been focusing most of my research time on in the past 5 to 10 years is on medical decision-making under uncertainty. All the questions in public policy about recognizing uncertainty and communicating uncertainty, they show up in medicine. I've dug deeply into the literature on so-called evidence-based medicine. As an econometrician, I can find all kinds of issues there. And so that's what the book is about. I will say, you're going to hear enough of me today, but you are in Berlin. Tomorrow morning at 10 a.m., I am talking about this at Humboldt with the second lecture Friday afternoon. So if you really want to hear about that's to a group mostly of statisticians, actually, but you could actually find out about that there. Okay, so that's a bunch of background stuff. Okay, let me go through some basics. And when I say this is going to be a part, there's a bunch of slides where things may be depressing internally for social scientists. One is this. This is, to me, is absolutely obvious, and I teach undergraduates. I start with it. This is in bold in my 2013 book. So how do we do empirical research? Is we combine assumptions and data to draw conclusions. okay? And what I say to the students, and what I'll say here, is that you've probably all heard about evidence-based research, evidence-based medicine, evidence-based educational research, evidence-based everything. Evidence is just a synonym for data. So when you hear people say evidence, or even better than evidence, when they use the word data, then they say big data. So it's big evidence-based research. And you say having data will solve all problems, or having evidence. It's not true. Basically, the only thing you get from evidence alone is just a historical record. There's nothing that's interesting that you can learn from evidence alone. Anytime any one of us draws any empirical conclusions, we are combining the evidence with some assumptions about how the world works. Now, the most obvious cases, and I know lots of people in here are familiar with so-called causal inference, the problem of unobservability of counterfactuals. You only observe what happened. You don't observe what didn't happen. We always have to fill in the blanks on what might have happened with counterfactuals. Those are assumptions. Now you say, well, you run a randomized trial. Well, a perfect randomized trial is a very nice thing to do, but it doesn't do magic. It works when it does work, because with a perfect randomized trial, you have a good assumption to make because you know that treatment was randomized. It's because of that assumption. People take it for granted. But it's that assumption that makes the randomized trial. And then, of course, if you dig deeper into literature and randomized trials, you find that, of course, it's very rare to have a perfect randomized trial. And there's all kinds of controversies and interpretations of randomized trials, never mind the controversies that we all know about interpretation of observational data, okay? So I'm always, whenever anyone's giving a seminar or reading anyone else's paper, they can go on and on about how much data they have, or how great the data is, but I want to know what the assumptions were that were combined with the data. And then, here's the question. Well, we want to draw strong conclusions, so why don't we just make strong assumptions? If we make strong assumptions, we can draw strong conclusions, fine. But are you going to believe them? So we get to this basic issue of credibility. Credibility is, I've been using that word for a long, long time. I think so many people in econometrics, applied econometrics, across the social sciences talked about credibility. Credibility is a clear thing. Is, do you believe the assumptions? I've written about something just as a soundbite I've called the law of decreasing credibility, which means that there's a tension. You can draw strong conclusions by making strong assumptions, but they'll be less believable. So the stronger assumptions you make, the stronger the conclusions, but the less believable. So this is a kind of a trade-off. Economists are very fond of understanding that there are trade-offs in the world, and this is a trade-off, that you can draw stronger conclusions, but maybe they'll be less believable. Now, some time ago, long time ago, I gave a talk on this, and I was going on and on about credibility, and someone asked me to define credibility, and I kind of stood there paralyzed because I really couldn't define credibility. After the seminar, I went to what I viewed as a definitive source was the Oxford English Dictionary, and this is really, at least a few years ago when I did this is what I found. The OED defines credible as capable of being believed, believable. It defines believable as able to be believed, credible. And then I stopped because I realized that, it wasn't going to get anywhere. I was thinking about you're talking about the definition of distinguished, thinking about a celebrity as someone who's famous for being famous, and it's a kind of a similarly circular definition. So we're just going to have to take credible, and the important thing about it is that it's subjective, it's not objective. The designation of whether something is credible or not is in your head. It's not something that's ever going to be resolved definitively. An issue for public policy that's extremely important is that researchers can disagree, and often disagree quite violently, on what credible assumptions are. And these can be pure scientific disagreements about how people behave. As has been talked about before, the disagreements between orthodox models of rationality in economics versus the various kinds of behavioral economics and so on. They can be ideological, things that are said to be empirical but are actually couched, come from different ideological views on how the world works. You can get these disagreements, and then often you can never resolve them, because we like to think, when we're taught in elementary statistics, about, well, if you got disagreement, then you do a hypothesis test, and you test the hypothesis. The problem is that a lot of the most important hypotheses are simply logically not testable. So people can claim forever on one side or the other side, and they can just talk past each other forever. And again, with the my American background, if you go to Washington, you see this all the time. Because around Washington, you have competing think tanks, and they all have positions on things, and they just argue past each other all the time. So we get, and it becomes a debating game where someone says, I'm going to maintain this assumption until it's proved wrong, and you know it's impossible to prove it wrong. Okay? So we get these problems. Now, my own view of the world is that social science would be healthier if we were all to just admit these issues and write our articles in a fairly straightforward, cautious manner that shows the tension between the strength of assumptions and the credibility. In practice, that doesn't seem to happen, particularly not around Washington. The general idea is economists say, well, people respond to incentives, and they don't face up to uncertainty because there are a lot of incentives not to face up to uncertainty. And it's true, I think, empirically. The scientific community rewards strong novel findings. It's easier to get your journal articles published if you have strong findings. If you said we did the best job possible, but we really couldn't tell in the end, chances are very high, subjective, my expectation, is that you're going to get your paper rejected, even if it's an extraordinarily well-done piece of work. A lot of us are upset about that. We discuss over lunches and beer that this isn't the way it should be, that the journals should be publishing articles based on how well the work is executed, but the practice doesn't change. And you can't even point to anyone on the outside. I said this is going to be depressing internally because we're all the journal editors and the referees who make this happen. So that happens, and that's inside the scientific community. Of course, when you go outside the scientific community to the public, it's even worse. The public isn't going to get all the nuance of this. The public just wants an unequivocal recommendation. We should do this or we should do that. So there are these incentives for certitude. Those are straight economic incentives. There's also an interesting connection. It's often stated very loosely as a psychological matter, but I've heard it said, repeatedly when I talk to people around Washington, that policymakers are psychologically unwilling or cognitively unable to cope with uncertainty. Now, I looked into that, actually, to see there's no literature. I might defer to political scientists on what we really know about how the cognitive ability of policymakers to deal with uncertainty. But what I did do, and this is in the article on the lure of Uncredible Certitude, I actually looked into the psychiatry and clinical psychology literature. And there turns out to be a syndrome. It's called intolerance of uncertainty. That's an actual syndrome. And I read some of the articles about this. But the clinical psychology literature states that only 4 or 5% of the population suffers from this syndrome. So, okay, so that's not really, going to get it. But people nevertheless say that you just got to give a point. This quote here, I've named him by name. He's like, we view each other as friends. You can't give, for economic consulting, you can't give the client a bound. The client needs a point. This is Jerry Hausman at MIT, who's an econometrician of my generation. I've known for many years. Jerry does a lot of economic consulting. He just says, look, if you try to express uncertainty, you're not going to get anywhere. They want a point, you've got to give them a point. It's also, to go across fields, this shows up in philosophy of science. I think everybody knows Occam's razor, the idea that you should express, that if you have multiple hypotheses or theories, pick the simplest one. They never explain what the simplest one means, but you're supposed to pick the simplest one. Well, why, if you have multiple theories that all explain the data and they're not crazy, they're all plausible, why should you pick just one? But Occam's razor says that you should, and people often adhere to that. So there are all these incentives to express certitude, but I just don't go along with this. Now, in my earliest writings on this, I set up this, and I've maintained it since then, a kind of typology of Uncredible Certitude that I want to go through just briefly. It helped me think about different categories. Conventional certitudes, like conventional wisdom, is a prediction or an estimate that is accepted as true but is not known to be true. The CBO scores of the debt implications of legislation are very much like this. I was very intrigued. I was actually working on this when the Obamacare legislation was going through Congress in 2009-10. That's when I was starting to think about these things, and I followed what went on. And with one exception, when the CBO came out and said that passing the Affordable Care Act would reduce debt by $138 billion in 10 years, basically every serious media outlet just picked it up and just quoted it as a fact. No one ever said, where do they get that number, 138 billion? Is it 130, you're going to reduce debt by 138 billion plus or minus 5 billion, or plus or minus 500 billion? When I talk to people who are health economists who do this kind of forecast, I mean, they say, oh no, these things are incredibly uncertain. Well, how much uncertain is it? Well, it's just uncertain. CBO just puts out the number 138 billion. So, but it was accepted. People argued actually, again, to connect with the political science questions, that actually settling on one number was actually necessary for Congress to do something. And, you know, and I can sort of see that you have to have something you can agree on, and if you don't, then maybe you'll never pass any legislation. Of course, we never pass any legislation anymore, but that was at a time when there still was legislation being passed. That's a possible argument, but I think one would have to really dig into it and do serious research in political science or organizational behavior research on that, you know, rather than just think it through in our heads. Dueling certitudes, I already mentioned, is when you get like these different think tanks that talk past each other, arguing that each of the one's wrong. I was highly influenced in my own career. In the 1990s, I chaired a National Academy of Sciences Committee on Illegal Drug Policy. There was a huge fight at that time. The emphasis then was on cocaine. Cocaine has totally receded now that we have the opioid crisis. At that point, cocaine was the issue. There was a huge argument going on between, it was basically a left-right thing where the liberals wanted to do drug treatment and prevention, and the right wing wanted to do heavy law enforcement and blow up the coca fields in Colombia. The Rand Corporation Drug Policy Center came out with a cost-benefit analysis, or cost-effectiveness analysis, they called it, which they said that the result was that drug treatment is far more cost-effective than anything you could do on the enforcement side. The Defense Department did not like that. They commissioned the Institute for Defense Analyses, which is a private organization, but very close to the Defense Department, and guess what? They came out with the opposite conclusion. This actually led to congressional hearings, because it was under the Clinton administration, and the Republicans who had control of the House then, they argued the Clinton administration was suppressing the publication of the IDA study. It turned out to be, and then they brought in this National Academy Committee, which I got in the position. I was named chair of the committee only because I had no previous history of doing research on the drug area, because everyone else was viewed as tainted, so they thought they'd bring in someone neutral. And it was a very educational experience. By the way, we concluded that neither study was worth anything, but that's all published. Conflating science and advocacy, I think everyone recognizes that we think about this flow of going from assumptions and data to conclusions. Sometimes you can go legitimately in the opposite direction. You say, well, in order to generate a certain conclusion, what assumptions would I need? Let's take the data as given. Sometimes that's a legitimate way to think scientifically, but often that is a mask for advocacy, that someone knows what conclusions they want, and then they're going to cook assumptions that lead to that. The example I've used in my writing is Milton Friedman's advocacy of school vouchers, so-called school choice, back in the 1950s. Because you go back, Friedman is a brilliant economist, but he was also a brilliant advocate. And if you go back and read what Friedman's writing on school vouchers, it's clear that he just wanted vouchers. And he knew the economic theory. There was no empirical work whatsoever. He could just put down the right assumptions to make that come out. So that was Friedman the advocate rather than the economist here. Wishful extrapolation is making untenable assumptions to extrapolate. The example I use repeatedly on this is extrapolation from the randomized trials in FDA drug approval, or it could be EMA drug approval in the EU would be the same thing. Let me broaden this out because I spent a lot of time on this on the new book on patient care under uncertainty. The entire, and these are, I'm going to use words that I think probably a lot of you in this room recognize, the entire medical research has more than anywhere else, certainly more than recent development economics research or labor economics research in the 1980s and so on, more than anywhere else has really caught on to the use of randomized trials ever since basically the 1950s. And the term gold standard comes out of, for randomized trials come out of there. The problem is, and if you go look at, and I've spent a lot of time now reading the medical literature, both the drug trials but also all the other randomized trials, is that we have this issue of internal validity and external validity. So these are the two words that many of you are probably familiar with. And even if you have a perfect trial, what it gives you is internal validity. It says absolutely nothing about external validity. External validity is the whole set of extrapolation questions from one patient population in the trial to a different patient population somewhere else. Extrapolation of the treatments, because the way the treatments are administered with blinding, let's say, of drugs and so on in a trial and other aspects of it is very different than clinical practice. There's the use of surrogate outcomes to measure outcomes in trials when you really want to get long-term outcomes. There's a whole host of things. And the medical literature, and I have to say, unfortunately, I think social scientists have basically followed to an undue degree what happens in the medical literature. They've taken the same stance that internal validity comes first and external validity comes second. That's Donald Campbell argued that back in the 60s and 70s, and social scientists today argue that, and I think a lot of the controversies about randomized trials are due to that. Illogical certitude, quickly, is simply just making mistakes. I don't think that happens often, but there is one very notable area of social science research with a history back to the 1800s where there were just logical mistakes made that persist to this day, and that's the research on heritability. All the stuff that uses analysis of variance and draws improper conclusions from twin studies and so on. It's just, the methodology is just flawed, and I could easily go into that if I had time. The final one I have here is not about focusing on what we do as the researchers, but since we're talking about communication of uncertainty, it's about the role, the translational role that the media play. Because if we're talking about public policy, it's one thing to get your articles published in the American Economic Review and other journals. It's quite another thing to have an influence. You've got to have the media pick up your stuff. And whereas the researchers are prone to incredible certitude, I think often the media, unfortunately, is even more so, is that what's going to sell things is saying, oh, this is fantastic research. Now, Raj is sitting right here, and these slides go back. I've been saying this for many years. So Raj knows that the article that I'm referring to was a very major article in which he was a co-author. And if you read what I wrote, and maybe you have, I don't know, but there's no criticism at all of your work. The criticism is entirely of the New York Times, because what happens, and I find this a fascinating story, is that there was a session at the MBER Summer Institute, 2010, 2010. I actually was there at that Labor Week, but I missed your talk. You had some slides, and on the very last slide, because you posted them, you had this, I think it was on page 52 of your slides. This was the bottom line, that having a better kindergarten teacher will raise life cycle earnings for the class by $320,000. You gave it as an exact number, so I can fault you for that. But the rest, it was an MBER Summer Institute thing. David Leonhardt was apparently attending, or he knew about it. Anyway, he wrote the article. And this got, based on slides from an MBER Summer Institute presentation. At the time, there was no the article was eventually published in the Quarterly Journal of Economics, but at the time, it was just a conference presentation. Leonhardt wrote an article, and it got actually put on the front page of the New York Times, which is pretty tough to do. So I said, what's going on with the media hyping a result in a conference presentation when there's been not only no peer review, but there wasn't even an article at that point, as far as I know. So again, this is not, it's just coincidence that this was, because Roger's so successful that he gets the New York Times attention, but this was an issue with the New York Times, and the media does play a role in this. Let me talk a bit more about CBO scoring. I know I can't get through everything, so I know what I'll focus on or not. The CBO case, I think, is particularly interesting. I've already described it to some extent. Here is going back to the Obamacare, or the Affordable Care Act. This is a quote from the letter that was sent by the director of the CBO to Congress. The Joint Committee on Taxation was involved because there was a tax act that was mixed with the Affordable Care Act. They say enacting both pieces of legislation would produce a net reduction of changes in federal deficits, the number I gave before, $138 billion over this period. And as I said before, this was accepted as a point prediction without anyone really questioning it, except for Douglas Holtz-Eakin as the only person who questioned it. He was a former director of the CBO, and he wrote a blistering op-ed to the New York Times that criticized his own former organization. So that's another matter. More recent example, this is on the Republicans' attempt to pass, fortunately we've forgotten about this by now, the American Health Care Act in 2017. And the CBO then says, just a couple of years ago, enacting the legislation would reduce federal deficits by $337 billion over this period. In this case, the more recent case in 2017, the CBO acknowledged uncertainty verbally. And this is very common, to say, well, of course there's uncertainty, and you can read exactly what they wrote here, but there was no quantification of the uncertainty. And if you just say, well, there's uncertainty, someone doesn't know what to make of it, so whether it's serious or not. So I'm always arguing for quantification of the uncertainty. What I've said, if you want a simple thing, just give a range, an upper bound and a lower bound. Obviously, you could give a probability distribution. There are various ways to do this. Now, I've mentioned before this idea about whether Congress can cope with uncertainty. I've talked with political scientists on occasion, and they say, well, you know, I haven't been able to find any research on this question. Anyone can anecdotally think of particular members of Congress who may or may not be able to cope with uncertainty, but I don't know of real research on the question. What I will say is that this may be peculiarly an American problem. Brits don't seem to have as much of a problem. If you look at what happens in Parliament, I think it's quite well known that for inflation forecasting, the Bank of England publishes probabilistic inflation forecasts that are presented visually as what's called a fan chart, and these are get widespread attention in places like the Financial Times and so on, the serious British media. There's also an impact assessment that's required for legislation submitted to Parliament, and that actually requires stating lower and upper bounds for the net benefits of a proposal. Now, whether that actually plays a role in the deliberations in Parliament, not so sure, but it's there in the laws. Let me move on and talk just a bit about official economic statistics. As I said, they are presented as point estimates without any recognition of uncertainty. These include employment, household income, GDP statistics, and so on. And I think it's actually very important for these federal agencies in the US, and again, I would say the same thing in Germany, to communicate uncertainty about official statistics, because there's a whole host of entities, governments, firms, private individuals who use these statistics, the economic statistics that come out every month or every quarter, as an input into the decision making. And if they get it wrong, if they don't understand the uncertainties, or if they miscalculate in their own heads the uncertainties, they may be making bad policy decisions. You could, if you go to the Federal Reserve in the United States, you could be making bad monetary policy. They're paying attention to what's supposed to have happened with GDP. If you actually see what goes on with GDP estimates, you know that there's a whole sequence of GDP estimates, and the numbers change quite a lot, actually, from month to month and actually from year to year. Let me just talk about that one in particular, I call that transitory statistical uncertainty. It's because they get initial, the thing about GDP estimates, there's initial data that comes in, and but they have to get reports from all the firms. But when the initial quarterly GDP report is due, maybe they have the data only from 30 to 40% of the firms, something like that. So actually that initial report is based on a trend extrapolation from the other 60%. Well, then the data comes in over time after that, and so they revise the estimates. There's an initial estimate, a second estimate, a third estimate, then after a month to month, and then a year later they do an update, and so on. The problem is that every time the GDP, that the Bureau of Economic Analysis and the Commerce Department puts out a new estimate, they say it's an exact estimate. So they may say, let's say for third quarter of 2019, they may initially say GDP grew by 1.9%. The next, and they say it's exactly 1.9%. The next month, they may recalculate that and say GDP grew by 2.9% that quarter. The third month, it may be GDP actually fell by 0.1%. And that's pretty broad range of changes, and you actually find changes of that magnitude. And they never once say, wait a minute, we're going to change this from month to month, so we should express some uncertainty. They just don't do that. The British government does. I'm going to skip over some things because I want to show you a fan chart. This is a fan chart of the Bank of England. This is actually for GDP growth, and this was done as of February 2014. You can get this for any period through to today. And so this is like the present when they do this. And this fan chart shows basically a forecast probability distribution for future GDP looking into 2014, 15, 16, 17. The really interesting aspect of the fan chart is that uncertainty is shown on past GDP. Because the Bank of England recognizes, these are for the past. They're sitting here in February 2014 and saying, what do we know about GDP in 2012 or even 2011? It's like 2 or 3 years earlier. And they recognize they're still in the process of revising those statistics. And so they actually put a probability distribution on past GDP. That, to me, is admirable. I mean, that is honest expression of uncertainty. Maybe there's a cultural difference between the United Kingdom and the United States that allows this to work in the UK and not in the United States. I don't get that. I spend a lot of time in London and other parts of what we'll see how much is left of the UK soon. But somehow they do it. In the United States, you just don't see it at all. So it is possible to do this kind of thing. Now let me. I also talk, that's transitory uncertainty. You can talk about permanent uncertainty coming from missing data, measurement error, and so on. I'm just going to skip this stuff just to mention it. There's also conceptual uncertainty, which I will mention just briefly. A major problem with uncertainty in official statistics is that sometimes the concept being measured isn't entirely well defined. And a quite important case for economics on this is a seasonal adjustment of macro statistics, GDP statistics, and related things. Because basically, it's at a very high level, everyone understands what seasonal adjustment means, but when you actually get down to it and operationalize it, people can't agree on how to do it. And it gets to be a very complex set of operations. I write here that the Census Bureau uses this X12 ARIMA method developed by the census. Maybe it works, or maybe it's an unfathomable black box that lacks any economic foundation. This is a quote that I love from Jonathan Wright at Johns Hopkins. This was in a Brookings paper. Jonathan Wright's an empirical macroeconomist, and this is his view on the difficulty of understanding how the Census Bureau actually does the seasonal adjustment. He says, most academics treat seasonal adjustment as a very mundane job, rumored to be undertaken by hobbits living in holes in the ground. I believe that this is a terrible mistake, but one in which the statistical agency should share at least a bit of the blame, and then he argues very cogently as a empirical macroeconomist that seasonal adjustment is extraordinarily consequential. Let me just give you a bit of an anecdote on that. When I was, which isn't on the slides, but it's in my 2015 article in the Journal of Economic Literature, and I was tracing back the history of a seasonal adjustment. I found that in 1962, Paul Samuelson, the famous MIT economist, Samuelson was mainly a theorist, but he was also highly involved in policy, and he served as John Kennedy's economic advisor. And the country was sort of coming out of a recession in most respects, but the employment numbers didn't look very good. And Samuelson wrote a long letter to the New York Times in which he reported that actually, no, the employment numbers are good, and the reason they don't look good is because they're using the wrong seasonal adjustment formula. And Samuelson redid the seasonal adjustment calculation in Kennedy's favor. So this goes way, way back. And I don't know whether Samuelson was acting as a scientist or an advocate then, but he certainly knew that the seasonal adjustment numbers mattered. Okay, let me say a few things to conclude. First, exhorting people to communicate uncertainty clearly in public policy is not a new idea. I quote here from Principles and Practices for a Federal Statistical Agency, which is a constantly updated, really nice volume from the Committee on National Statistics of the National Academy of Sciences, and you can read this through yourself. It says all the things that you should do about being careful with the data. To go back much earlier than this, when I was at some point in my thinking about the topic, I went back to 1950 and then 1963 when Oscar Morgenstern, whose name may be known to some of you as von Neumann and Morgenstern, co-inventor of modern game theory. Morgenstern was just, after he wrote the book with von Neumann on game theory, he just got incensed by the failure of government. He developed a very practical streak and was very incensed by the failure of government to face up to uncertainty and all the official statistics that I was just talking about. And he wrote a book in 1950 on the accuracy of economic observations, and then a second edition in 1963. And this may seem like a really dry topic, but Morgenstern is just, if you just read it, he's just all riled up. He has quotes in there. He says, this is just a travesty. We shouldn't believe any of these numbers. We should stop doing business cycle statistics because you can't believe any of this stuff. And Morgenstern was very famous, because of the game theory work, but he had no impact. So I can take that as evidence that I will have no impact either, because he was more famous than I am, for sure. But I nevertheless think that it's quite important. And so I will rant on about it. As I said before, the practice has been to acknowledge potential errors verbally, but not quantitatively. Certainly, the news releases, you don't expect much in a simple news release. But even the technical documentation from the CBO or from Bureau of Labor Statistics and so on, they will verbally talk about uncertainty, but they won't try to quantify it at all. If there's anything at all, it'll be about simple sampling imprecision from random sampling, statistics textbook 101 kind of thing. All of the non-sampling issues, which are the really big issues about the nature of the sample that's drawn, missing data, measurement error, and so on, and these conceptual issues, there's nothing on that. I think that the statistical agencies and the CBO in particular would better inform policymakers and the public if they were to measure and communicate all these uncertainties in the work they do. Now here's a big question, and I keep again I've mentioned since we have political scientists here, it's a question for political scientists, for organizational analysis, for behavioral economists, for a whole host of people. And I keep asking people, what do we know about this? Or I keep hoping I can find someone write a good PhD thesis or whatever to take this on. Is that if we were to change the practice and to communicate uncertainty in a more honest, credible way, how would that affect decision-making? How would it affect public decision-making? How would it affect private decision-making? we currently have just very little understanding. I mean, we could all talk over coffee about this, but when I'm talking about serious research on what do we really know about what would happen if you were to communicate uncertainty more seriously. Right now, I just worry that some people don't understand this uncertainty at all. They take the statistics at face value. Other people are more sophisticated, and they know this uncertainty, but they have no idea of the extent of it, whether it's minor or major, and so they have to guess at how big the problem is. So I think this is a good topic for WZB, right? I mean, this is an interdisciplinary social science center, and I think making progress on this topic would require the expertise of people from a wide variety of social science disciplines. So let me pose this as a topic for WZB. I'm not quite finished. That ordinarily would be the end of this talk. Unfortunately, there's been one more, I've been talking about this topic, I've been working on it for about 10 years. Unfortunately, in 2016, I had to add this postscript. So it's just one slide. This is the relationship between my depressing talk about the internal world and Jennifer's depressing talk about the external world. What I write I try to do it in a measured way. I tend to, I have my own strong political views like anybody does. I tend to try to leave them out of my writing. Economists don't really feel comfortable explicitly writing about these things. But I do think 2016 was different. And I've stated this in print. This is in the Proceedings of the National Academy of Sciences actually allowed me to say this. I was a little bit surprised. Basically what's up on this slide. So we've got a period not only, I've been talking about resistance to expression of uncertainty, but now we have like total unconcern with truth. I use the term post-truth, which is, it had like a 3-month window when people used the word post-truth, and then it morphed to fake news or something else. But I like post-truth right after the election, and so I keep using that. And how I write the president, I mean, it's no surprise. The president appears incapable and unwilling to distinguish fact from fiction. Here's the issue for me. I've had various people say to me, yeah, you're right about uncertainty. We should all express uncertainty. It's right. But it's a second-order problem now, that in a world where people are just lying outright and won't even, talk about basic facts, there's kind of a luxury to be worried about uncertainty. That we should at least get back to, I think, again, going back to Jennifer, she talked about lost nostalgia. There never was a period when truth was king in the United States, right? So I'm old enough, as some of the rest of us are, to know that there was never a period when truth reigned supreme. But I still think there's a huge difference between now and the way it was. And so you might say, look, we just got to get back to the way it was, and if we ever succeed in doing that, then we can worry about uncertainty. I actually disagree. I can't that we can put the concerns about uncertainty to the side. I can't prove this from research. It's a gut feeling. But I have the strong feeling that when we as researchers, when we talk to each other, and even more so when we talk to the public, that they, we say things and we say that we know them, and we want to use their word again, credible. And if we overdo it, if we succumb to the lure of incredible certitude, then they're not going to believe the things that we say. And actually there could be, I'll go so far as to say, maybe a slippery slope, that if you push your conclusions too far, then people say, well, I'm not going to believe anything these guys say. So what I write, and I will end with this, is that if scientists want the public to trust what we say we know, we should be upfront about what we don't know. And I'll stop with that. Thank you.
Thank you very much, Charles. Now we have time for a discussion. I don't have a microphone, but I'm trying to shout, so maybe that helps. So we have a number of questions. First of all,
this is terrific. Thank you. So I can't resist your invitation to Can't resist your invitation to at least ask a question, not give any answers about the politics. It seems to me that this is a collective action issue from the perspective of policymakers or advocacy organizations or elected officials.
Yeah.
That let's assume for the moment that you're exactly right, which I'm perfectly happy to do, and that they would be better off, and they know they would be better off. The third assumption is bigger, but let's assume it for the moment. But you can't be the first actor, right?
No.
Because any agency that says, well, you know, we got a confidence interval, blah, 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 but we think actually the death's going to go up, not going to work. And any elected official who says, well, I actually think this is probably a good idea, but, you know, there's a reasonable possibility it actually could turn out to be terrible, isn't going to work.
Yeah.
So how does one get from here to there, assuming that everybody agrees we ought to be there? It seems to me that there's a huge collective action issue in getting...
Yeah.
Nobody can be the first mover, or even the second or third or fourth. You got to sort of, everybody's got to move simultaneously. Because the
Absolutely.
political disadvantages are so strong.
Okay, so to change the language from political science collective action language, which was perfectly fine language, to change it to economics, it's a game with multiple equilibria. I think that's exactly the situation, is that there are multiple equilibria. We're in a very inferior equilibrium, I think, where no one in a decentralized way can move away, can violate the social norm or, stick the necks out, whatever you want to call it. But somehow society has to move from the bad equilibrium to the good equilibrium. And that's always a problem. I mean, game theorists, study problems with multiple equilibria, some which basically sort of Pareto dominate others, but just kind of stuck at the bad equilibrium. Macroeconomists are always worrying about these things. How you actually do it, I don't think the game theorist is so good at figuring out how you move from one to another. So I can't. And that does go back to the collective action question. I'm sort of wary of just conjecturing, but you talk about the president as the leader, the only centripetal force. Well, obviously, this president's not going to do that. But occasionally, there are people in the past who had enough trust that they could serve as leaders. I don't think it would take that many trusted people, let's say, in Congress, and there are some sensible people in Congress, obviously, or to get together and say we should, with some of the heads of the statistical agencies, to say we should do this. And they could get help from the National Academy of Sciences Committee and so on to do it. I think these things are doable, but I don't have a prescription for exactly how to do it. But I think that's exactly right. We're in an inferior equilibrium right now.
Yeah, thank you very much for your talk. I was wondering, I guess you know the work by Gerd Gigerenzer?
By whom?
Gerd Gigerenzer, who is, because...
Oh, Gerd Gigerenzer.
Yeah.
I've never met him. I've certainly read it. Is he here in Berlin? Or?
He is in Berlin, yeah.
No.
But the issue is, and that fits very well to your talk. He did a lot of research on medical doctors, so that's why I was thinking that you might have read him, showing that they have huge problems with probabilities. And they make wrong decisions if they use probabilities. If you use instead simple heuristics, more like natural frequencies, and then you're much more to your point estimates, then they, in more cases, not in any case, but in more cases, they make right decisions. And so I was wondering how you would, uncertainty is one thing, but it's also the knowledge you have to know to interpret what you make out of the uncertainty, whether that is large or whether it's small. You can't just. So do you have any idea?
I could probably. I can't go on for hours because I don't have that time. The particular thing, or Gigerenzer's, which I certainly am aware of, about this is a communication strategy about using frequencies rather than probabilities, and he had huge arguments with Kahneman and Tversky about this, which I think a lot of people know about. To me, I don't care whether you pose something in frequency terms or probability terms. In the work on measuring expectations that Dorothea mentioned, we use a percent chance scale, and we've done this with tens, now hundreds of thousands of people almost across the world, where we say, what's the % chance that something will happen? And ordinary people seem to be able to deal with that. Now, I don't know how what Gigerins in particular would think about that, as posing it in frequency versus. The question I would really want to go on, though, to spend, if I had time, spend more time on, is that some things actually you cannot express probabilistically at all, whether in probabilistic or frequency terms. If you look at the kind of methodological, technical research that I've been doing for the past 20 years, it's on what's often called ambiguity or deep uncertainty, or what macroeconomists call Knightian uncertainty. These are situations where you have uncertainty for sure, but it's not ones where you can't credibly put a probability distribution. So this is not standard Bayesian kind of uncertainty. This is, you just know that something might happen, but you can't put a, so you go read my technical work, and it's all about using max-min and minimax regret procedures and so on. In the book on patient care uncertainty, which is a verbal book, I wrote it to get all the math out. I actually try to explain minimax regret to medical doctors, and we'll see how many understand that. But the point I want to make for you is that uncertainty, I've focused on, maybe it's easy to think about probability distributions, but there are types of uncertainty that are much deeper and in which so it's even worse.
I'm here. Hello? I'm here. Do you see me?
Oh.
Yeah, I have a microphone.
Okay, I see you now. Yeah.
So, thank you very much. Very excellent talk. My question is about your last slide. I'm wondering, how do you answer the question, very simple question, do you live in a post-truth world? Yes or no?
Does who? Me? You?
Yes or no?
We.
Do we?
I think we're in the midst of
Yes or
of
no?
a huge struggle, which has not yet been determined.
So if you answer yes, it's not true.
No, I never. My wife who's sitting here knows I almost never give a yes/no answer to anything, because I always see nuance and everything. Let me take you maybe not in the direction that you intended, but I will say it since we're sitting here in Berlin. I've been to Berlin before. I haven't been to WZB, but I've been to Berlin. The first time I came here was in '91 to visit Humboldt. It was right after the reunification. We walked to Alexanderplatz yesterday. It looked quite different than it did in 1991. In particular, Potsdamer Platz was entirely rubble back then. And it actually made me, I'm going to have to say, something hopeful. This made me very hopeful, okay? And I have to say, this is why I cannot give a yes/no answer, because things change over the time. I'm Jewish. My father was a Holocaust survivor. He got out of Eastern Europe just luckily in spring of 1941. If this were 80 years earlier, in 1939, I could not possibly be standing here. Okay, it would just obviously have been impossible. And so if you ask in Germany in the 1930s, during World War II, and during World War II, are we living in a post-truth world? Yeah, Germany was living in a post-truth world under the Nazis. But Germany came out of it. And Germany today is nothing like what it was then. So that's why, I mean, being very serious, I would refuse to give a yes/no answer, because these things can change with time. And the United States is in a very rough situation now. I feel kind of odd. I know Germany's got its political problems too, but it actually feels like a breath of fresh air to come here relative to what we're going through.
Thanks a lot for your talk. So you raised the issue that often you don't communicate when talking to politicians or in the news the uncertainty. So I intuitively I don't see the. It's clear to me, because it's very, very difficult to explain what probabilities and what uncertainty means to somebody who hasn't studied statistics, who hasn't dealt with statistics in university, I think. What I'm more baffled with is that you say the Congressional Budget Office just reduces one single number. And, so I've like 10 years ago as a student assistant. I've worked in some, like we've produced some reports for the Austrian government, and there we didn't include, the exact like uncertainties. But what we did was we calculated certain scenarios, under this assumption that the economy will grow slowly or very fast, that people are gonna die sooner or later, health expenditure will rise or fall or whatever. And doesn't the Congressional Budget Office even do that? So I'm really astonished.
No, they're not, and I didn't have the time to go through the details. I do not blame the CBO for this. In their official role from the Budget Act from 1974 of scoring, the interpretation, this is not in the legislation. I've actually read the legislation. It was in later interpretations about how to operationalize the idea of scoring, is that a group was put together. They're actually called the scorekeepers. This is the heads of congressional committees and so on. And it was the operational rules said that they would produce one number. Now there are other reports that the CBO does, which are not the official scores, like they may do a GDP forecast or something, where they will express uncertainty. But in the official role of scoring, the interpretation, although it's not really in the legislation, is that they will only give a single number. I've talked, it was Doug Elmendorf, is he the Kennedy School now, right? Yeah. Doug Elmendorf was the director of the CBO then. I talked with him one-on-one. Doug's a smart guy, and I talked with various other people. There were staff there who I taught, as PhD students, and they all said, we recognize the uncertainty, but they all unanimously said, we can't do it. Congress does not want to hear uncertainty. And that was, now, did they test it? What would happen to them if some director of the CBO were to do it? They were really afraid. I had Douglas Holtz-Eakin, and I talked to him on the phone. He said that Congress would drop CBO funding if they were to express uncertainty. So, this may be a peculiar, America's got lots of peculiar things. This may be one of them, but apparently you just can't do it there. Now, back to your earlier point about whether people can understand probabilities. I don't agree with you on that. You don't need university-level courses in probability and statistics to really get this. People deal with uncertainty in their day-to-day lives. The weather forecast with the chance of rain and so on, everyone sees every day. We all are constantly making decisions under uncertainty. We're deciding who to marry, what kind of jobs to get, whether to travel by bus or car on a particular route when there may be congestion. No one could be dealing with these things in deterministic ways. It doesn't mean that they can do Bayesian updating in their head accurately, but that's not the issue here, as to whether they can conceptualize uncertainty. I think most ordinary people can.
So I have two questions. One is just I love this fan plot you had with the
Bank of England
uncertainty going back in time, but I couldn't understand why there wouldn't be a big discontinuity now. Surely we know more about the past than we know about the future. So I was wondering how they're
why
thinking.
it's so continuous.
Yeah, why is it so continuous? There's no jump, right?
Well, it's because there's no jump. But the data are coming in slowly over time. It's basically a continuous process where month to month they're getting more data.
But still we know more. Whatever they don't know about the past, they know more about it.
Well, I have to go back. I didn't cook this, Photoshop this slide. Yeah. This comes from the...
I'm just not that certain
I
about
think it was, I don't know if I could...
About their procedure, yeah.
It looks fairly continuous, I agree, if I can, here it goes. It looks like it's a little bit bigger to the right, but not quite. It's what it is.
Okay. So my second question is, I guess, I can understand. I completely agree. There should be studies on this. I haven't seen them, and they sound very, very doable. You could certainly worry that you tell a policymaker, it's between 5 and 15, and they choose whichever one they like, is consistent with. And there are studies on agency drift in this kind of situation where there is discretion, but. You said people understand probabilities, but I certainly know graduate students who are pretty savvy, or many colleagues, many people have real difficulty knowing what is meant by a confidence interval, really. And
Well,
people
confidence intervals are some of the most misunderstood things.
It's a very tricky idea, and people reinterpret things in Bayesian terms very quickly and have the sort of...
These things are much simpler. The confidence intervals, everyone, they're frequentist and everyone interprets them as if they're Bayesian.
Yes.
Anyone who teaches statistics knows the difficulty of teaching that. But these are simpler. On the work on measuring expectations, the Dorothea. So this is done, like a big, the health and retirement study in the United States are a share in all the, so some of you may know Axel Boschespan, who, where is he now? He wasn't? In Munich now. So he runs this for all the EU, not just. They ask all these people questions like, what's the chance that you'll live to age 75? What's the chance you'll live to age 85? What's the chance you'll retire by age 62? What's the chance you'll leave a bequest? You're asking people questions that affect their own day-to-day lives. And we have the data, and basically the response rates are like 98, 99% on those. And the numbers make sense. There's like lots and lots of research literature on this. Those are the kinds of questions I'm talking about. I think the confidence interval case that you mentioned is conceptually a much harder thing to understand.
Yeah. So I guess the question was, might we be better off if we tried to produce credibility intervals, or some sort of estimates of Bayesian uncertainty, given policymakers' priors or something?
I don't want to take a firm stand on the best way to do the communication. Let me to be constructive about this, because I just don't consider this my field of expertise, but there are people who spend their careers doing it. There are a small group of psychologists, and I'll mention, obviously Gigerenzer would be among them. The people I know best, the old friends, Baruch Fischoff at Carnegie Mellon, or David Budesco, who's in New York now, and Tom Walston, who works with him, they really focus, as psychologists, focus on communication of uncertainty. A woman I met at Northwestern, Jessica Hullman, who's both in our computer science department and the journalism school, she focuses, like Baruch and so on a visualization of uncertainty and how to communicate these things in a way to make them understandable. This is not my expertise, but these are very serious academics who, from whom I think there's a lot to learn. Yeah.
So I'm going to be provocative and sort of change the level here a little bit. So you ended with trustworthiness of science, and it seems to me that concern about uncertainty is the least of our problems. Not the biggest of our problems.
I said people tell me that all the time.
So I think about competing findings. You mentioned the cocaine studies. There's also the recent case of the minimum wage or $15 wage studies, which are affecting direct policy right now in places like Seattle, which you're studying. I'm thinking about changing findings. We keep being told red wine is good for us. It's not good for us. Coffee is good for us. It's not good for us. And that, of course, is not a probability problem so much, though there is a probability issue there. Then there are frauds and the incentives in academia to fudge data, which seems to me an increasingly serious problem, certainly being brought to light right now. And finally, there's a very different kind of problem, which is, and I have to confess that I am addicted to a television show called The Good Place, which is, The Good Place is heaven, but it's really hell. I won't go into the complexities of this story, but there's a moral philosopher in it who is being tortured because, given uncertainty, he cannot figure out what the right thing to do is.
Okay, so you raised so many. Let me leave the fraud case out. I think that's different. But let me talk about the cases. Let's talk about the moral philosopher, if I remember at the end. But you said that the cases, let's say on minimum wage, you get competing results from different studies. I recently published with John Pepper in the Review of Economic Statistics on the effect of right to carry laws on crime, which is very controversial in the U.S. Those are all subsumed within, they're not separate, they are subsumed within what I mean by uncertainty. They're not separate. Because for my own work in econometrics, the kind of uncertainty that I've spent most of my career studying is not garden variety statistical sampling uncertainty, but it's rather the uncertainty from identification problems. The whole problem of analysis of treatment response from observational data, or in randomized trials, if you get non-compliance, and this, and this, and this. And when you go in, and I've talked about, to draw conclusions, you combine data with assumptions. Every single time that I dig into the literature where there's some controversy where people get different results, or it could be on nutrition stuff too, right? Because that's like changing all the time. There may be some differences in the data, but typically the main difference between studies is not at all in the data, it's rather in what assumptions people are using to combine with the data. So here, I don't want to talk about Raj's income tax files because he has a unique ability to get data that others haven't been able to get. So let me take as a leading example the right to carry stuff. The right to carry, so for again, another, Americans and guns, you know the peculiarities. So the question of what, if you allow citizens to carry concealed or open handguns, will that decrease crime or increase crime? The data on this is exactly the same in every study. There are dozens and dozens of studies. They all use exactly the same data, which is a state-level administrative data on crime rates for different crimes, and a 0-1 variable basically for whether concealed carry was allowed or not allowed in that state. And the time series is basically the same. The data was originally put together by John Lott, who was a very big advocate for one side of this in favor of guns. And then there were various, John Donahue was at, I think now at Stanford Law, he did a public service putting out, everyone uses the same data. You get all these studies using the same data and the results are all over the place. And you have to dig in. This is what looks like dry statistical detail to an outsider. But to an econometrician, it means you got to dig in and say what models were they using with the data. And you find out that these huge differences in conclusions are because people are using different models.
But that doesn't give people trust in science.
Well, this is why, no, this goes exactly back to my concern with Uncredible Certitude. Because my work, because I don't know how many of you are familiar, I mean, this is what I do 90% of the time, is study what we call partial identification, which means doing inference under weak assumptions and that you hope are credible. And if you do that, I generally don't get a point estimate of anything. This goes back 30 years now. So for me, it's second in my students and lots of, some degree in others. And you told me you've used some, so that is I don't produce point estimates. I'll produce bounds on things. And sometimes the bounds will be narrow and sometimes they'll be wide. The research that you're talking about, the conventional approach, is not to use weak assumptions that have high credibility. It's to use these strong assumptions with low credibility, and then people get these very different results. And then then you can lose faith in science. This is within uncertainty to me, and my pitch has always been to do your empirical research with weaker assumptions, and if you get bounds, then you get bounds rather than a point estimate. So now this is a more on the moral philosophy. The fact that you're uncertainty about something does not mean you cannot make a decision. Because there's a whole literature on decision-making under ambiguity, or decision-making under a deep uncertainty, which is all about kind of reasonable criteria for decision-making in the face of uncertainty. And I mentioned minimax, regret, and maximin before, so those are some of the classical ideas that show up in that literature. It doesn't mean that you're paralyzed. Yeah.
Doesn't mean you have to be.
How was that?
It doesn't mean you have to be, but there are an awful lot of policymakers who are.
Well, then, so why? Why are policymakers more than...
They're not more, but they have a different kind of impact.
Yeah.
So thanks so much. I thought this was extremely helpful and, of course, agree with the ideas you've laid out. I wanted to get your perspective on two things. So one case where I think the public is very comfortable discussing sources of uncertainties in the context of polls, where I think it's systematic.
Sampling uncertainty.
Sampling uncertainty in
sampling.
particular, not the broader
Yeah.
notions of uncertainty we're just describing, but curious why you think in that context, margins of error are pretty routinely reported. And then second, distinct, but maybe potentially related, I think the decision theoretic approach that you were discussing at the end, of course, makes a lot of sense in terms of thinking about what people are going to do with this information. I'd be curious what you'd think of this rationalization for providing just the mean. So if you think the loss function is quadratic or approximately quadratic or something like that, you could potentially justify with certain objective functions just giving people the mean. Now, of course, that may not always be the case. I think the poll example is actually a good one, where it matters a ton if you're a little bit under 50% versus over 50%.
It's not a quadratic loss function for
so
sure.
yeah, highly non-symmetric loss function. So yeah, I'm just curious your thoughts on those two things.
What Roger's referring to about the end is about technical work on decision theory about what's a sufficient statistic with particular if you want to maximize this or minimize that, and it's certainly taught to every economics PhD student that for prediction under square loss, the mean will do it. But that's the case where you have a full probability distribution. But of course, that's a very special case, right? On the polling, it's interesting. Part of the horror of, I usually wouldn't talk this, but after Jennifer talked honestly about the election, part of the horror of being at home watching television on election night 2016 was to watch that goddamn needle, on the probabilities that for the non-Americans, of course, you didn't know this, that first it starts off with Hillary Clinton having like a 98% chance of winning, and then as the evening goes on, it goes slowly, it goes like this, and then it goes like that. So I think I don't know who was that from, Nate Silver or someone, but some things have changed. I think there's more awareness of uncertainty in polling now than there used to be. Unfortunately, it still is the case that they don't get under the deep issues about the really systematic biases and who's answering the questions and whether people are answering honestly. But at least it's a start that people do recognize that. And they certainly do in the weather forecasting. Yeah. So there are some areas where we have role models. Yeah.
Great.
Okay.
I think